Hello, my name is Afshin Odabai. Welcome to New Horizons LabCam. In this presentation, we're going to talk about the DC-DC micromodule family, specifically the ones that we have designed with very low noise operation. Both the very low radiated noise, the low EMI, and very low conducted noise, which make them very suitable for high-speed multi-gigabit rocket I/O and SerDes applications. Let me tell you briefly about the DC-DC micromodule family. Incidentally, if you'd like to know more details about them, please refer to the introduction to DC-DC micromodules, which are on the New Horizons website. Just briefly and quickly, the micromodule family are complete DC-DC systems with a DC-DC controller die, MOSFETs, the inductor, input-output bypass capacitors, and the compensation circuitry on one package. This one example, we show the top side of the LTM4601 family. It's a 12-amp design, and the back side is an LGA packaging. We have a high-power 12-amp, single output, or have dual outputs. Devices operate up to 28, up to 36 volt on the input, depending on the device itself, from 12 amp down to 200 milliamps. We just talked about the micromodule regulator systems and what they are. Let's talk about the new generation and new devices that we just introduced. We call them the Ultralow Noise DC-DC micromodules. These devices are switch mode, high efficiency, high power, with very low radiated noise for EMI sensitive devices, and also very low conducted noise, which make them very ideal for powering multi-gigabit SerDes and rocket I/O applications. We're going to talk about what it takes to power high-speed SerDes device. We talk about the comparison of heat and the noise and the size of a solution. We're also going to probably briefly just talk about the eye diagram. These are the results we have received from our colleagues at Xilinx testing the LTM family with the rocket I/O. On the second part of this presentation, we will talk about the EMI applications, and we have some test data to show. We have also obtained some certification for CISPR 22 low noise, low EMI systems. In this presentation, we talk about specific about the LTM4606, but there are three other devices which have been tested by Xilinx for the rocket I/O: the LTM4604, LTM8023, and a dual output LTM4616. A high-speed transceiver system requires a very clean and quiet power supply. That's to minimize interference with the integrity of the data being transmitted, and usually that's measured with looking at the jitter and the eye diagram. Historically, linear regulators have been used to power these devices. Reason has been linear regulators don't have a switching element on board, and they don't use inductors, therefore very low noise. The issue recently has been as the speed on the transceivers has gone up and also power consumption has gone up, linear regulators mostly in most designs become very hot. So the designer has to deal with the heat dissipation and thermal management by adding heat sinks, adding fans, or perhaps higher speed airflow, and adding more copper to the PC board. And these are usually become expensive. The other solution is to use a power supply which is higher efficiency than linear regulator, which is switch mode regulators. These devices, however, do have inherent noise generation because they're using a switching transistor and using inductors to do that. So in terms of the EMI and conducted noise, they have higher noise level or they produce higher noise level than the linear regulators. Let's talk about the second aspect of the noise, which is talking about the radiated noise from switch mode regulators. We just talked about conducted noise. In the EMI sensitive systems, the amount of energy that the switch mode regulator can produce in terms of electromagnetic energy can interfere with the quality of data being transferred from a receiver to the transmitter. The solution usually has been with the adding ferrite beads, magnetic shields to the device itself, or perhaps very knowledgeable PCB layout designer has to pay special attention to the layout. And also the design could be often very bulky by adding the components, and it does require experienced designers to do so. With the introduction of the Ultralow Noise DC-DC micromodule family, linear technology has addressed the high efficiency and also low noise in one device and we're going to talk about in detail as we go on. Linear Technology has been working with Xilinx Rocket I/O design team for about a year and a half or 2 years to introduce this family. The first device is the LTM4606. This device is a complete system in one package. The silicon itself is 100% Linear Technology DC-DC controller silicon, and also the MOSFETs are designed by Linear Technology and is fabbed and tested by us. We have a special substrate and special layout to reduce the noise. The inductor on board is shielded for low EMI. The device itself has a very low profile for easy airflow, for very, very efficient removal of the heat from the system. These devices don't require any kind of special tooling. They look like a regular standard surface mount IC. And we also have a very good reliability data available. As an example, we have over 8 million device hours with power cycle with 0 failures. This slide that you see shows the LTM4606 front and back side. Is an LGA package. And for the Rocket I/O testing, we have introduced 4 devices in total for different kind of voltages and different kind of currents for the designer. And these have been tested by Xilinx on the Vertex 5 GTX Rocket I/O test board. The LTM4606 is a 6 amp micro module. Has a very wide input voltage range from 4.5 volt to 28 volt, so it's suitable for 5 volt and 12 volt input applications. The output voltage can be set with only one resistor, very simply, from 5 volt down to 0.6 volts and up to 6 amp on the output load current capability. The pictures you see here are plug-in boards provided by Linear Technology for Xilinx Rocket I/O test group. These boards are plugged into Xilinx test boards to qualify and verify the performance or the noise performance of the switch mode regulators. The bottom of the page on the left hand side is a snapshot of jitter tolerance testing done on the BERT scope, courtesy of Xilinx. And in summary, it shows that the LTM4606 passes all the jitter tests and eye diagram tests for very clean power supply for Rocket I/O. Let's look at the test results from Xilinx Rocket I/O test group, comparing the results of the LTM8023, LTM4604, and the device we just talked about, the LTM4606, and a dual output LTM4616, compared to a noise performance of the linear regulator from Linear Technology, again, LTC3026. The jitter tolerance test and the eye diagram quality test has been performed against a very simple low noise linear regulators. But all the LTMs have passed Xilinx, and this proves that the LTMs, being very simple designs, as simple as a linear regulator, although they're switch mode, they have a low noise performance, and what they offer is simplicity and higher efficiency at higher output power. To obtain free demo boards, please contact New Horizons. You can also contact New Horizons in order to receive Linear Technology DC-DC micro module plug-in boards. You can also contact them if you'd like to obtain Rocket I/O Vertex 5 ML52X characterization board. This concludes this presentation of New Horizons LabCam for DC-DC micro module family, specifically the low noise products for Rocket I/O and low EMI applications. I'm Afshin Odabayi from Linear Technology, and thank you for watching.